So the last speaker of the session is Max, and Max is going to talk about overhead displays, so multimodal and then display on overhead.
Hello everyone, my name is Maximilian Nabokow. I am from the University of North Carolina at Chapel Hill, presenting GlassMessaging, which is work that happened at the Human-Computer Interaction Lab during my time at the National University of Singapore, led by Nuwan, Janaka, and Shengdong. So for some background, what we're targeting here is messaging. Messaging is something we do all day, every day. And surprisingly, a lot of it we do on the move. And we do that in situations of situational impairment, where you can run into a bus, fall over, etc. So lots of health risks and situational impairments that we choose to accept because we want to continue messaging. And that is exactly the situation that we want to address with GlassMessaging. This is kind of an overview of our work, but I'll dive into more detail in a second. So for the overview of what we did, we first want to identify the pain points that users experience when doing messaging in a multitasking setting. So we did a survey and an observation. And then once we have identified those pain points, we want to identify how we can use an OHMD to target those pain points and support messaging during everyday daily tasks. We did an iterative design of an application and then compared the GlassMessaging application with what we're used to texting on your mobile phone. We started with a survey to identify the pain points and identify in which situations our users are most likely to message in a multitasking setting. And the ones we choose to focus on are on transportation and eating alone. I'm sure that's what we all do. Then during the observational study, we checked for the common difficulties that our users experience when texting in those settings. And we found that both the hands busy and the eyes busy situations are most difficult because you're having to switch your attention back and forth, or your hands might be busy with a primary task and texting with wet hands while washing the dishes is difficult. So those are the common difficulties we found. To then address that, we first checked how existing mobile applications would work on existing OHMD hardware. And that's a bit of an overview on the side. We found that most of the existing applications simply ported over are pretty unsuitable. The colors are off, the sizes of interactive elements are off, and overall the interactions are just not designed to take advantage of the OHMD platform. We then went through an iteration and developed our GlassMessaging application, which is a multimodal interface that combines audio input and manual input through voice messages, voice navigation, and everything that we had on our OHMD platform with ring mouse and mid-air gestures, and outputs both visually through the head-mounted display and gives you audio feedback. And the best way to show you this interface
GlassMessaging towards ubiquitous messaging using OHMDs.
These are interactions. I can talk about these in a second too. You'll see them in the video.
Show chat. Richard. Voice message. Sure, see you. Send. Hi chat. Open keyboard.
So here's another quick overview of all the interactions we have. The entire interface can be navigated simply with your voice, which is good for situations where your hands are busy. But when you're in a situation where you don't want to use your voice, you're able to use a ring mouse to navigate the entire interface, and you can hide the entire interface when you want to have full eyes attention on your environment. And then in study 3, we go and compare this interface with what we're used to from texting on mobile. This we did in a controlled setting where the primary task you'd have to do is walking to eat snacks in the kitchen, which is a multi-step task that took multiple minutes. And that whole time, you would also have to do a secondary task, which is send a given text message to a given contact. We did this for both short messages and for long messages. And to show you what the study setup looks like, we have another video. This is what you do on the mobile phone. You have the participant doing their main task of preparing food, eating food, washing the dishes, while also texting. And you can see some common issues there already. And this is the situation on GlassMessaging,
Do they have some conflicts here?
where someone's able to send messages while washing the dishes, for example.
Text Jack. I hope you're feeling better. Text John. Text Vivian. Okay, I'll talk to you later. Hi, chat.
So for the results, we found that there's no direct difference in task completion time, which is good. But we found that the message count, the number of messages one would send in a specific time frame on GlassMessaging was more, because you wouldn't have to stop your texting to do the primary task. You wouldn't have to stop the primary task to do texting. The texting speed was much better because mainly of voice dictation, and the response time overall was shorter. The perceived effectiveness of the interface was also better than on mobile, and the one thing you would pay in is texting accuracy, which comes down to there not being a super accurate text input and dictation being spotty at times. Overall, the advantages are that the voice input on OHMD is much more natural to use than on your phone. You don't have to stop and press some dictation button. You can do this while walking around. It's wearable, it has multiple inputs, and the perceived trust of this private interface is also valuable. Overall, the messages you see are much more timely. You can respond more quickly, and there's potential for improving social connection there. Overall, the ultimate question, which one is better for messaging? And the ultimate answer, it depends. It depends on the situation. You're trading efficiency and trading being able to do both a primary task and a secondary task for a bit of accuracy. The voice input can also be limited. You don't want to be publicly announcing your messages on the bus. Overall, we believe that OHMDs will be the next communication frontier and can be useful as a complement to mobile phones during messaging. Thank you.
I'd like to invite all the authors to come up front. And Wal, is there any quick question?
Hi, thank you for showing the cool video demo. I was wondering, because you motivate your study to solve the problem of situational impairment, I wonder if you measured or quantify or assess situational impairment in your experiments, comparing like phone versus the on-head display.
Yeah, we did most of this by checking the actual outcomes and checking the results of how many messages you would be delivering. And combining that with the information we found during our first study, where we checked for your common issues. That's what we did that.
Thank you. So let's thank Maximilian, and we move on to clap. Great.